Question number 1. What is light?
What'd you ask me?
Let me be clear. What is light?
2,000 years later.
Light is when...
One eternity later.
Light is that feeling when you see a woman. No, when you see a man and you see his arms and you see his chest, but you can't do anything because society says you can't. Look, if you want to listen to your teachers as they tell you what light is, go ahead. But if you want to know what light really is, I'm your guy.
You can't define light, man. So if you define light, you define yourself. And that's just what the government wants you to do. Don't define light.
I am light.
I think for physics, like in a physics term, I think light is wonder, as I said. Can I reference Thomas Edison over here? Okay. Well, he tried a lot and he had a lot of failures, but when he found his light, I think for him it would have been the best feeling in the world. But light is also happiness. It gives a lot of joy to people. But ultimately, I think light is finding your direction, wherever it is. It's hard to get to it, but once you found it, whether it's in your relationships, your careers, dreams, desires, your ambitions, I think once you found your light, it is the best feeling. So that's what light means to me.
Light is electromagnetic radiation, moves at 3 times 10 to the 8th meters per second, can be described as a wave or a particle, and can't be fully described using classical mechanics.
Here we are now demonstrating our next experiment on bending light using water. We've been taught in school that light travels in straight lines, or else that's what we think. In this experiment we will show you how the light that we project will be bent through the flow of the water. Now in the experiment, we were projecting the laser beam horizontally to the other side of the bottle where a hole was present, allowing for the water to flow out. Pay close attention to this. The laser beam is following the laminar flow of the water. So technically in the experiment, the light does not bend. The water stream acts just like a fiber optic, which in return channels the light to follow it. When the laser beam hits the water, it is reflected in the water. It is important to understand that the surface of the water is reflective, both on its surface and below the surface. Since our environment was slightly dark, one can easily see the reflection. The phenomenon that we are witnessing is called total internal reflection, which happens when a propagating wave strikes a medium boundary at an angle larger than a particular critical angle with respect to the normal to the surface. Now, the critical angle is the smallest angle of incident for which light is totally reflective. So, in conclusion, when the beam crosses the critical angle, the light does not go out of the stream. And what we witness is the total internal reflection phenomenon that takes place.
In this experiment, we'll show you Newton's well-known prism experiment. This is how light behaves at the end of the boundaries between the two materials. For instance, a planar boundary, the ratio of the sine of the angle in each side of the boundary is fixed for a given set of materials. The one on the bottom left is a form of Snell's law, where the ratio of the sines of the angles is equal to the inverse of the refractive indices of the materials, where the refractive index of the material is related to how fast light propagates through it. We kept turning the prism to get a clear and visible color spectrum. As you can see on the white surface, the colors are not that prominent. Trust me, it's not as easy as it looks. Here, as you can see, we use the triangular prism to split white light into the colors of the spectrum. The white light composed of many colors is going into the prism. Every color will bend or refract slightly differently depending on the material properties of the glass. Red light is bent least while the blue colors are bent greatest. As a result, white light going into the prism on one side emerges as a refracted spectrum of different colors. Then we tried refracting the light through a convex mirror and noticed something really weird. When we rotated the convex mirror 360 degrees, the order of the colors changed. We tried refracting the light through an aluminum plate and noticed something amazing. The sunlight not only splits into its expected colors, but also in some very surprising colors. Isn't this beautiful? In the end, through this experiment, Newton showed that every color has a unique angle of refraction, which can be calculated using a suitable prism. He saw that all objects appear to be the same color as the beam of colored light that illuminates them, and that a beam of colored light will stay the same color no matter how many times it is reflected or refracted. And because of that, we can conclude that color is a property of the light that reflects from objects, and not a property of the objects themselves.
So for our final experiment, we used a laser pointer and the transparent part of a DVD to display the behavior of light. Here we are attempting to point the laser in a certain direction and location so we can see the strand of light that has been diffracted by the film. Just like in the daylight, there is a rainbow effect on the top of a CD or a DVD. This was meant to mimic an experiment performed by Thomas Young during the 1800s. He performed this experiment to reveal that light behaves a lot like a wave. In some instances, you will notice the diffraction of the single ray of light into several slits which have been branched off of the original one. There is a pattern of presence and absence of light, and the density of light decreases as it goes further away from its center. This makes it evident that light follows the concept of wave-particle duality.